Hi, good afternoon, everyone. Welcome back to the new episode of the Machine Learning System Singapore seminar. And today we are very fortunate to invite Matthew to be our speaker. Matthew is currently final year PhD candidate in the NLP group at NTU in Singapore, and he is being advised by Shafiq Jyoti and Sun Aixin. And he's under the Singapore Scholarship, where he's also attached to the A-Star I2R Ali Lab, where he's supervised by Dr. Nancy Chen. Matthew is on the job market, source scientist job in the industry in Singapore. Interested to please feel free to reach out to him. Thank you. Thank you, Matthew, and the floor is yours.
Okay, thanks a lot for this info. So hi everyone, I'm going to present a recent survey paper, which I co-authored, which is about ChatGPT versus open source large language models. So the title is ChatGPT's 1-year anniversary, are open source large language models catching up? So we uploaded it to archive end of November 2023, exactly 1 year after ChatGPT was released, which was end of November 2022. So this is a collaboration between myself, colleagues from NTU NLP Lab, and our supervisor, Shafiq Jyoti, and his colleague, Kaiming Xiong. You can see the archive link here, and as well as the GitHub link here. In the GitHub, we are maintaining live versions of the tables. And whenever we see a new LLM, a new open source LLM, which is high performing and above some of ChatGPT capability, we are updating it, putting the link and results into that GitHub. So please feel free to check those links and comment. If we're open to all suggestions, if we miss out anything, please tell us and we'll update. We keep updating that survey. So I'll first talk about the motivation behind this work, then I'll present the results, and then finally give some discussion about key elements that we're highlighting here. So first, some motivation. So as we all know, ChatGPT took the world by storm around a year ago, end of November 2022. It's famous for having reached 100 million users worldwide within just 2 months, which is incredibly fast. It's faster than YouTube, TikTok, Instagram. The traction behind ChatGPT has been huge, and now there's much more than 100 million people, and then there's been more versions since with greater capabilities. Latest versions of ChatGPT have a longer context, and they keep releasing new versions pre-trained on more data and more powerful. Unfortunately, ChatGPT is closed-sourced and it's controlled by OpenAI, which is a private company, which means that to this day, we are not sure about its architecture. Like things like the number of parameters are unfortunately still unknown. There are some folks commenting about it on Twitter and making some educated guesses, but it's still not official, like how big ChatGPT is, right? I think one of the best estimates is 20 billion parameters. But most importantly, the pre-training data, the fine-tuning data, all of this is unknown. The good thing is that since ChatGPT was released, a lot of folks in both academia and industry have released open source large language models, which are publicly available. People can tweak the architecture, check the parameters, etc. And that's famous examples include Llama, Falcon, Wizard LM, Llama 2, Mistral, which is just 1 month old, etc. So relying on closed source models like ChatGPT is not ideal, as we know, and those are some of the reasons why this is not ideal. The first obvious reason is that it's behind the paying API, so there's a heavy cost of calling the API. This comes into play, for instance, if like me, you're working on long inputs task. I'm working on long input summarization now, where input text easily exceeds 10,000 tokens, and you don't work with ChatGPT or GPT-4 on tens of thousands of data points once that's the case, right? Because you'll quickly exceed whatever budget you have for the API. There's also a lot of data ownership and privacy issues. It's quite hard to properly estimate the risks to society because everything that's linked to the way it was aligned, this was designed internally by OpenAI. We don't really have so much information about it. Another kind of unforeseen issue that people have noticed is that performance can change and degrade over time. That's not ideal, right? When we're like, if you're building a product relying on ChatGPT, and then if suddenly like 6 months later it's not working as well, customers may be unhappy, and there's nothing you can do about it. So for instance, there's a study from Stanford and Berkeley showing that the code generation capacity of GPT-4 and ChatGPT decreased between March and June 2023. Sometimes the API is down. There's some model outages that happened twice, just in November 2023. And last but not the least, there's some boardroom drama sometimes at OpenAI, like as you heard about Sam Altman had to leave the company, only to join back just a week later. So like who knows what might happen next, and how reliable all of this API is, and for how many more years. So those are like the disadvantages of relying on the closed source model. Fortunately, we also have the option of using open source LLMs, and open source LLMs bypass all of the issues mentioned above. So in this paper, these are the contributions that we make. So we're providing an unbiased and comprehensive view of open source LLMs versus ChatGPT. We try to include as many, like all possible open source LLMs that we found. We'll systematically review these open source LLMs that match or surpass the performance of ChatGPT in various tasks. And then each time when we find such a setup, like a task and an LLM where the LLM is obviously above ChatGPT, we give some analysis, try to understand what made it this way. We also present some discussions and give insights on the trend of open source LLMs development, the good practices to train open source LLMs, and potential issues as well, loopholes. I'll conclude with this, current loopholes with LLMs, and especially their evaluation. All right, so that was a bit of a background. Now let's go into the results. So that's the bulk of the paper. Is about comparing the open source LLMs against ChatGPT and GPT-4. But that's quite an ambitious task. I mean, there are many possible evaluation benchmarks for LLMs. How to organize it is not trivial. We decided to break it down into 6 dimensions. The first dimensions is like general capabilities. So those are things like just multi-turn conversation capability of the LLM, global world knowledge. The second dimension is agent capabilities. So this is about how the LLM can make use of tools, calling web APIs, do self-debugging, etc. The third dimension is logical reasoning. How is the LLM at tasks involving reasoning, like math problems, coding problems, like writing functions out of some strings. The fourth dimension, which is one of the remaining technological bottleneck in language modeling, is long context capabilities. How is the LLM doing long input summarization or very long input QA? In the fifth part, we're analyzing specific applications, like how is are LLMs that's specific, like domain-specific tasks, like maybe healthcare or finance. And lastly, we analyze trustworthiness. How is the LLM at hallucinations, or like AI safety as well. So that's overview of how we break down the evaluation. Now let's delve into it one by one. So here's the first evaluation dimension: general capabilities. So for this one, we're reporting empty bench results, Alpaca eval. Initially, we had the first edition. Now we have Alpaca eval 2.0 in the table of the paper, as well as Open LLM leaderboard. So this is a leaderboard maintained by Hugging Face, which is behind a lot of the libraries being used in language modeling, like transformers, datasets, tokenizers, PEFT. They maintain this leaderboard of open LLMs. Usually when there's a new powerful LLM, they claim that they're currently at the top of the open LLM leaderboard, only to being surpassed like 2 weeks later by the next best OpenLLM. That's what we've observed in the last 6 months. So we can show all possible data sets here, but just to know like some overview. And we're highlighting that but we have Llama 270B chats, so the instruction tuned version of Llama 270B, the largest Llama 2, Wizard LM70B. Those are quite competitive. In the first version of Alpaca Eval 1.0, they were above GPT 3.5. In the 2.0 here, actually, they are dragging on a bit behind GPT 3.5, but E34B is actually outperforming even GPT-4 on Alpaca Eval 2.0. So it's currently the best on this one. For empty bench, the OpenAI models are still reigning on top. The best open source one is Mixtral 7B so Mistral 7B with 8 mixture of experts, so which is called Mixtral. So that one is just behind GPT 3.5, and potentially the next version will surpass it. Yeah, same with OpenLLM leaderboard. Like currently, the best open source LLMs are just behind GPT 3.5, like a point or 2 points behind. But what we see as well is that GPT-4 is still very strong. Like on OpenLLM leaderboard is still quite ahead of all the others. It was the case as well on Alpaca Eval 1.0. Notably, like the difference between GPT-4 and GPT 3.5 on Alpaca Eval 2.0 is very, very large. Yeah. So in the last version of the paper, we're concluding that currently, as of like January 2024, Mixtral 7B is probably the best open source LLM. So you can see here its performance on the left on several dimensions. We compare Mixtral 7B with Llama 2 70B chat, Wizard LM, and GPT 3.5 Turbo. So Mixtral is 10 times smaller than Llama 2 70B, which is the one in red, but it's much better on all the benchmarks. So MMLU, Alpaca Eval, MT Bench, and Elo rating, and even like on par or better than GPT 3.5 Turbo, which is ChatGPT. Yeah, so as of now, Mixtral and E as well is very strong as an open source LLM. Now moving on to agent capabilities. Here we highlight this open source LLM Lemur 70B. So usually open source LLMs are released in different model sizes, 7B, 30B, 70B, and as well as just pre-trained checkpoints and instruction tuned checkpoints, which are like the checkpoints usually. And usually the largest instruction tune or chat version is the best one, and that's the only one we report performance of. So that's the case here with Lemur. The best version of Lemur is the biggest one at 70B chat version. So on this agentic task, which are mostly coding or reinforcement learning tasks, Lemur is quite strong. So it's above GPT 3.5 on AlphaWord, on ICCTF, and also on code generation and following natural language feedback for code generation. So Lemur, the main ingredients in this model is that they perform continual pre-training. So they continue the pre-training for quite some so for another phase, but not as large as the first pre-training phase, but they pre-train again on 90 billion tokens, both for code and for language modeling. So that gives a lot of coding and agentic capabilities to the model, which I think the base model is the Llama 2. So they continue pre-training of Llama 2, but with more emphasis on the code data. And after this, again, do some supervised fine-tuning on 300,000 samples, and that leads to this high agentic capability of Lemur. Now for logical reasoning, for that dimension, we use two very famous evaluation datasets for LLMs. So GSM 8K, that's 8.5 thousand grade school math problems. And human eval, that's small evaluation datasets from OpenAI. So 164 handwritten programming problems with test cases, on average 7.7 of them per problem. And what we see is that so we have wizard math is outperforming GPT 3.5 by quite a large margin. Same with Lemur that we saw before. Lemur 70B chat is better than GPT 3.5. On GSM 8K, GPT-4 is still the best, right? Still 10 points above the second one with our math. On human level, this new model, OpenChat 3.5, is better than GPT-4. Yeah. And so these models, these wizard models, wizard coder, wizard math, they take the idea from wizard LM, which is applying the evol instruct idea they basically derived a better instruction tuning data. So in the case of wizard coder for coding, in the case of wizard math for math, they derive better instruction tuning data just using LLMs, so without humans in the loop. And making sure that it's quite large, diverse enough and large enough, and then the instruction tune on it, and that leads to these powerful models. We're also reporting the results of Phi. So Phi 1 is outperforming GPT 3.5 on human eval. So Phi is a much smaller model, only 1.3 billion parameters. So for LLMs, that's really at the lowest end of the size. And Phi pre-trains on a dataset cleaned with the help, they used GPT-4 to filter pre-training data and also fine-tune on a dataset created entirely with GPT 3.5. So heavy distillation here, but that leads to a very powerful small model. Now moving on to long context abilities. So for long context, zero scrolls is a very popular benchmark. So zero scrolls is an aggregation of several tasks. So we have, so the setup has to be zero shot LLMs, right? That's why the zero. So it's an aggregation of long input tasks. We have summarization, two generic summarization tasks, gov report and sum screen, and two query focus summarization tasks, QM sum and quality, followed by 4 question answering tasks, and then 2 custom aggregation tasks introduced by the benchmark. So they have a sentiment aggregation task, as well as reordering summaries of book chapters. On this benchmark, we're reporting 2 models. So Llama 2 Long, which is a new iteration of Llama 2 tailored for long input. So again, what they do here is they continue the pre-training, just continue with a longer input context, starting from initializing from a Llama 2. And Llama 2 plus retrieval, in that case, they combine position interpolation with retrieval. So position interpolation is a way to extend the context window of LLMs. And you can adjust to that new context window through a small phase of fine-tuning. You don't need too much data, like a few thousand points usually is enough. It's a very elegant idea to increase that context window. And retrieval is yet another way to increase the effective context window. In that case, that paper, they combine both worlds, and they show that both methods are complementary. And that yields a powerful model. So with retrieval, they're around the same, a bit behind GPT 3.5. Llama 2 Long is actually the best one on some tasks. So it's better than GPT 3.5, even better than GPT-4 on some of the tasks. So on QM sum, for instance, Llama 2 Long is actually the best. Narrative QA as well. So it shows that adjusting through some continual pre-training can be very, very powerful. Okay, so Yeah. Moving on to hallucinations, another evaluation dimension. So for hallucinations, there's not like a really clear standard way to evaluate yet, but there are a few data sets which are used for measuring hallucinations. So most of them are question answering data sets like Truthful QA or Open Book QA or Trivia QA. There's also Fact Score and some open source LLMs report better performance than GPT 3.5 Turbo. So we have Cove, so chain of verification, critic. Those are methods proposing to self-revise outputs of the LLM, right? So the LLM will generate a first answer and then condition again on it, but like perhaps enhanced with some other tools like retrieval or it could be any enhancement, and then it will revise its previous output. COK, so chain of knowledge, will enhance with retrieval, KSL with knowledge graphs, PKG is another method, and enhancing the LLM inference by accessing some, like assuming the LLM is black box and also assuming access to other white box models. Each of these methods actually outperforms GPT 3.5 on at least one of the reported datasets. Sometimes with quite a big margin, as we see chain of verification on fact score 13 points above GPT 3.5. All right. So here's an overview of the development trend of large language models over time. So you can see both open source ones and closed source ones. So the open source ones are on top of the line. The closed source ones are below. So it all started with GPT-3, now 3.5 years ago, mid-2020. Then Google proposed a lot of, Google and DeepMind proposed a lot of models, but they were not publicly available. They were huge, pound reached like 540 billion parameters, I think. Then ChatGPT was released with this powerful RLHF capability and instruction tuning. And then that accelerated developments, like especially of open source models. So after ChatGPT, Llama, 3 months after this, Llama was released by Meta. And Llama also really accelerated development of open source large language models. Some of the most recent ones include XGen by Salesforce, Phi by that we've seen, Llama 2 and Phi that we've seen, Mistral as well, E that I've talked about. One of the latest closed source ones is Grok from XAI. Unfortunate that it's closed source. But the trend we see here is that there's an acceleration. Like there are two conclusions from these figures, that closed source ones were preceding open source LLMs. However, in recent months, recent period, open source LLM development is accelerating, and there's more and more open source models being released and published, and this is where the community is going. We're going to like open source, powerful large language models. Okay, so to wrap up the results, we can list a few techniques which are enabling improvements in large language models and enabling them to sometimes, maybe not always, but at least on some on the desired evaluation data set, surpass GPT 3.5, aka ChatGPT. So for pre-training, it can be beneficial to pre-train on higher quality data, which is the approach followed by Phi, or to inject new capabilities during the pre-training phase. So you can pre-train with retrieval. That was done by Instruct Retro, for instance. Quite a popular technique is continual pre-training. So adding that other round of pre-training after the first pre-training. So one way to do this is to continue pre-training on data of different natures. So for instance, if the model is mostly pre-trained on language, you can do continual pre-training with more code. That will give it some, make it better at coding applications, obviously. So that's what Lemur did, and that was very effective or you can continue pre-training with a longer context. That's what Llama 2 long did to enhance the context length of Llama 2. So continual pre-training is a very successful approach, but it requires quite a lot of resources. Other approaches include enhanced instruction tuning. That's what the Wizard series of models did, Wizard ML, Wizard Coder, Wizard Math. Those are not the only models doing it, but I'm just giving a few examples for each technique. We noticed as well that on some tasks, standard task-specific fine-tuning can be quite powerful and is the best method. So that's the case, for instance, for Mentalama or Struct Bench or Shepherd. Fine-tuning on data of higher quality, so filtering the quality of the data can be very effective for instruction tuning. That's what Platypus emphasized on. There are also methods to enhance the knowledge that the model has access to. So that's more usually inference time methods, like a chain of knowledge, for instance. We also highlight that on some domains, such as AI safety, GPT 3.5, and especially GPT-4, remain completely out of reach. So we hypothesize that this is probably due to a better reinforcement learning with human feedback. The RLHF for alignment is done in-house at OpenAI in a much better way than other labs have been able to do it so far. So we try to give some best practices for large language models. Ideally, assuming enough resources to pre-train, then you want to pre-train on trillions of tokens, but that's obviously not possible for all labs on the planet. But there's a paper describing the relationship between the size of the training data and the size of the model in terms of parameters. This is called the chinchilla scaling laws. And for current size of models, the tens of billions of parameters, usually pre-training has to be in the trillions of tokens range. For fine-tuning, you can use much less data, but quality is what's important here. So for fine-tuning, higher quality data is required. For architecture, as of now, it seems that the world has converged to decoder-only deep transformer. It's quite successful, but that may change in the future. The UL2 paper was comparing architectures and objectives and highlighted that encoder-decoder can still be very powerful. Some papers propose to add tricks, especially on the attention mechanism. For instance, ghost attention in Llama 2 or sliding window attention on Mistral 7B. Usually these make the model run faster, either for training or for inference. Now for training, supervised fine-tuning with instruction data is compulsory. And again, what matters here is not really the quantity, but more the diversity and the quality of the data. The paper quoted here is Lima. They show that you can instruction tune with only like 1,000 data points and still reach comparable performance to models instruction tune with 50,000 data points, as long as those 1,000 are very, very high quality and diverse enough. For alignment, RLHF with PPO, this is super important, especially for model safety. Recently, an alternative was proposed, which is DPO, direct preference optimization, and a paper proposed to distill it to optimize a smaller model. So this is Zephyr. That works as well, very well. For inference can be quite slow. There are methods proposed to accelerate inference. Speculative decoding, we highlight it as a very promising one. VLLM as well, the VLLM framework as well. Those are popular techniques to accelerate inference. Now, to conclude, so there remains some major loopholes in the evaluation of LLMs and specifically open source LLMs. So we're trying to highlight a few here. The first is data contamination. That's going to be more and more critical, we foresee in the next few months and years. So that this is the issue that evaluation data, all of these benchmarks we've seen that where people compare LLMs, which are released one after the other, trying to beat GPT 3.5 and maybe GPT-4. This may all be flawed because evaluation data may have been seen during pre-training, either partly or fully. This is very hard to evaluate actually because pre-training data is just so big that just looping through pre-training data and checking if each of the evaluation data point is there, we cannot do this. It's too computation intensive. And there's also the issue of paraphrasing. It could be already there, but not with the exact same words, kind of paraphrase. In that case, that's still a little bit cheating. So this is an unsolved issue. So how do we solve data contamination? And what a few researchers have been saying is that models are not really zero shot anymore. So they've just seen so much data in pre-training that when you claim that they are very powerful in this zero shot task that they were not instruction tuned on, but they can still solve. Well, actually, they're not really zero shot. Right? They actually saw something like this in the pre-training data. There's also the issue that now we've seen there are startups focusing on building a better open source large language models, and they have a conflict of interest here because like depending on the score that they claim that model can reach, that's going to be easier for them to reach a greater audience, potentially to raise their next round, etc. So it's in their interest to claim models are being better and better on those benchmarks. But if data contamination is not assessed and solved, then those numbers cannot really fully be trusted. Another issue is the closed source development of alignment. So RLHF for alignment preference data, we know it works well, but only a few open source LLMs actually use it. And one issue is because there's not enough good and open source preference data sets out there. So the community needs more of these to go forward for alignment. Improving pre-training data mixtures, for instance, for continual pre-training, we've highlighted this as a very promising direction. Unfortunately, this is very costly to explore. You need to vary different data mixture and pre-train each time, and each pre-training run probably is out of reach for 90% of academic labs. So that's unfortunately that's quite a bottleneck as well with LLMs, with open source LLMs. Another direction is those techniques distilling from either bigger models or from closed source LLMs directly. Like a lot of papers propose to either build the data sets with GPT 3.5 or GPT-4, use the data sets to instruction tune the open source LLMs. That works. That will give you a high performing open source LLM, but it's still distilling from that more powerful closed source ones, and so it's still kind of bounded by that source LM, the teacher one. So this might reach this approach might reach an upper bound soon, and so we need more. We need alternatives to just sticking to distillation. Yeah. Okay, so that's the end of my presentation. Thanks. If you have any question.
Thanks, Matthew. And if any one of you have any questions, feel free to raise your hand or unmute yourself. Okay, maybe I'll just begin. Thanks for the amazing presentation, and you are one of the most interesting things I draw from your presentation is that you mentioned that during the fine-tuning stage, that you place a bigger emphasis on the quality of the fine-tuning data rather than over the quantity of the fine-tuning data. And how should we define the quality of the data in your terms?
Yeah, thanks. That's a very good question. Well, yeah, quality could be many things, right? So especially for instruction data, it could be more detailed and complex list of instructions, longer and richer outputs. To properly assess it, you need a human evaluation. Humans are actually going through the instruction tuning data and then annotating it. One way to evaluate it, to define quality, would just be to ask GPT-4. GPT-4 probably would do a good job at this. But again, then we fall back to distillation, and we might be bounded by capacities of GPT-4. Yeah, but I mean, I can talk about my specific research area is summarization, right? In summarization, like a huge issue is actually the quality of the data sets. So the data sets that have been used so far are not really built, from scratch by humans. Rather, they are sourced, they are scrapped from the internet. Like one of these data sets is called XSum, and the way it was constructed is that people just crawl the BBC websites for BBC news articles, because they noticed that on this website, like the first sentence is highlighted and kind of summarizes the entire article. So they said, okay, let's build a summarization data sets where we just chop off that first sentence. We say this is the summary, and then the rest of the article online is the input. And then we call it XSum because it's extreme summarization. You compress into a single sentence, which is very abstractive, a lot of information in it. So sure, that why not? But then that led to a catastrophic data set, which is very noisy actually. Like there's a lot of hallucinations in that data sets, meaning facts in the summary which are never mentioned in the source. They may not be wrong, but they just were never there. So if you fine tune a model on that kind of data, you're encouraging it to produce facts which are not to output facts which are not in the source that you condition on. So you're basically encouraging hallucinations, right? So this is not high quality data as opposed to high quality data where you for instance try to avoid any of those hallucinations. Or sometimes in summarization assets you just have like, hopefully that doesn't happen so much, but not really grammatical kind of expressions. So in high quality data, this is rigorously checked and assessed that everything is long enough, grammatical fluence, not hallucinating, like all those properties are verified. So yeah.
Maybe a data set that can mimic the what a human will respond, or how the human process the information.
Yeah, exactly. Mimicking how a human would write the answer to it. Unfortunately, we don't have enough, human annotators on hand to write from scratch.
Not having
So
enough
thousands of,
interns,
yeah,
hire more
we,
interns.
yeah, we need tens of thousands of data points. Each of them, ideally, each of them written from scratch by a human who takes his time and do it properly and double checks everything. Yeah, but GPT-4 can be used as a tool to go in that direction.
Thanks. If not, I have another question. So, you mentioned the data contamination problem, and one of the in your benchmark, I think they one of the first few benchmark that there's a E3B model where it excel in the Alpaca Evo benchmark. I couldn't recall which one was it. It was one of the first benchmarks in out of the six test where you have the YI3B model. Yeah,
Uh, yeah, E34B on Alpaca Evil 2.0. They claim, this is currently the highest one on Alpaca Evil 2.0.
yeah. They just seem too good.
Yeah, yeah. I'm not sure. Who knows? But
Yeah.
I agree, especially between Alpaca 1.0 and 2.0.
Mm.
On 1.0, GPT-4 was really dominating completely. But on 2.0, E is quite ahead. Like yeah, it's especially compared to the other open source ones, right? It's like almost
Yeah,
twice the next open source ones, Mixtral. And Mixtral itself is very good, very strong. So
true.
yeah, I mean, I don't know, we cannot assert if there's any
Yeah.
contamination here, but like, contamination is really, really critical issue. Like I should have mentioned it when I talk about contamination, but
Mm.
there's some very interesting work recently where some people prompted models, with the same token. Like they found this jailbreak into ChatGPT that if you just prompt with the same token and repeat it many times, sometimes ChatGPT goes crazy and then suddenly outputs like pre-training data.
Oh.
yeah, like you prompt with like the or and it also prompted with like I think company like 500 times with something not seen. You never, it's completely out of distribution from natural language. You never see that kind of like continuation of the same token many times on text online, or it's very, very rare. So then it elicits this weird behavior in the LLM. It might suddenly like regurgitate some data it's seen during pre-training,
Mm,
and then they even like were able to get some like personal like information from some people, like name, like resume, like company. So it's very scary. Contamination, yeah, is quite critical. There are a few works trying to like, first measure, if one data set is contaminated, or you can do it at the data set level or at the data point level. You know, you could check if that specific data point has been seen, or uh, which is other than just checking if overall on that data sets it might have been contaminated, because that performance on average on data sets is quite high compared
mm,
to other. Also, that could be because of contamination.
mm, Maybe we can even uh, reverse engineer this process and to identify whether a dataset has whether a model has used contaminated datasets or leaked datasets to pre-train. Like, um, I'm thinking about because most of the datasets were scrapped from the internet, and if we assume that the data cleaning process was not done properly, and the image contains the HTML headers or a lot of the HTML tags. And if we can identify some of the uh, tags, like, then we can maybe ask the ChatGPT to complete the use, maybe say begin HTML something something. Then and we ask them to complete the whole thing. Maybe it will uh, output the training data set, or it have anything I have seen so far, or hmm.
Yes, like what you just highlighted is one way to tackle contamination. If you prompt with the beginning of a long data point, uh, if it's able to continue it perfectly, and matching like the exact tokens,
Hmm.
that could be the sign of contamination. Uh, However, all of this is rendered more difficult by alignment, specifically
Ah.
OpenAI. They have a whole big team of researchers making sure GPT 3.5 and GPT-4 are aligned. And as part of their recent alignment efforts, they are blocking things like when you ask ChatGPT, like when you give it like a data point and ask to complete, it will not do it. It will refuse because this behavior has been injected in the alignment phase, so they will not do it.
That makes
Auto
sense.
completion, even yeah, auto completion will not work anymore. Yeah. So
Ah,
you have
that
to.
makes sense.
There are other ways you could, for open source models, you could check the confidence,
Mm,
by asking it to complete a sentence. If it's extremely confident on each token,
mm,
could be a sign that it has seen that series of token before.
mm,
It remains an open research issue, and I think very interesting for NLP labs to try to work on this.
mm. Thanks. Do we have any questions from the floor? Um, Maybe I'll just ask one more question
Okay.
before close, if you don't mind. See, in your benchmark, you use both the base version and the chat version of the models, and I'm wondering, which one would perform better in general across the benchmarks?
Actually, usually we use the chat version.
The version.
Usually the chat version or instruction tune version is better. Uh, yeah, like 99% of the time. Like there might be some cases where the base version could be better. But no, by default we go with the chat version or instruction tune version. So yeah, in this table we're showing Lemur, like both the base and the chat one. because the base one was quite high performing, almost on par with ChatGPT. But you can see the chat one is much higher than the base one. Yeah, here's the chat. Here, all of the versions are the chat, the instruction tune versions.
Gotcha.
Yeah.
Thanks so much.
Thank
And
you.
for anyone who is interested in more details about the design of the experiments and benchmarks, please refer to Matthew's paper. And I think you have the link on the second slide, or
Yeah, we have
so the people can.
the papers on archive. And feel free also to reach out on GitHub if you want us to add a model or data set that we've missed.
Cool.
Okay.
Okay, if not, we'll just call it an end. And thank you everyone for your participation. And especially thank you, Matthew, for the amazing talk. And we hope you everyone have a prosper and healthy new year in the coming year. And look forward to your everyone's and we look forward to new talks. And there will be new talks coming.
Yeah, thank you for having me today. Bye bye.
Thank you, Matthew. Thank you, everyone. Bye bye.